the lecture on MAC protocol and ad hoc wireless sensor issues, ad hoc wireless sensor network issues. So ad hoc wireless sensor network, I have sometimes written ADWSN or ASN certain times. So you should understand what is that ad hoc wireless sensor network. And what is MAC protocol? So full form of MAC protocol is medium access control. So in one room, I'll tell you what is MAC protocol first. In one room, suppose you have deployed some 8, 10 or maybe 20 sensors. Then in that room, the only thing from where the data is retrieved is the channel. So channel in that room is nothing but the air. So if there are 20 sensor nodes deployed, then each sensor node is allotted with 1/20th of the overall bandwidth. Let's say bandwidth is B. Okay, so if 20 sensor nodes are there within that same area, so whatever bandwidth B is being shared by 20 sensor network, 20 sensor nodes. So each sensor node is having B by 20 bandwidth of some megahertz or kilohertz something. Now instead of 20, if within that same area I am deploying 1000 sensor nodes, but the bandwidth is not changing, bandwidth is B only assigned to that area by some kind of transmitter. So in that case, that bandwidth B is being shared by 1000 different sensor nodes, because instead of one we have deployed, instead of 20 we have deployed 1000 sensor nodes within that area. So each sensor node will be having reduced number of bandwidth. So how much bandwidth will be shared, will be available by each sensor node? In that case, it will be B divided by 1000. So previously 20 nodes, they were sharing B by 20 amount of bandwidth. It was quite wide bandwidth. Now as number of sensor nodes we have increased, we are going to see that the bandwidth is reduced for each of the sensor node. So what is actually bandwidth? So bandwidth is a kind of a capacity or information capacity of a node. So if bandwidth is more for any node, that means that node can carry more amount of information from one place to another. So connectivity becomes better if each node is having a wider bandwidth. But if number of nodes we are increasing in a certain area, in that case what we are finding is the bandwidth is suddenly reduced, and if bandwidth is reduced, in that case each of the sensor node cannot carry information as it was carrying previously. So information carrying capacity of the node reduces if you are increasing number of sensor node within that area. Okay, so this is the bandwidth issue, or this is the MAC protocol issue. So what is medium? Medium is nothing but air. So bandwidth is getting reduced if we are increasing number of ad hoc sensor network. But then also by increasing number of sensor node, then also how can we get the best connectivity between the source and destination? For that, certain rules are established. What are those rules? Okay, so if you follow that rule, if every sensor node follow that rule, then even if it's a very dense ad hoc wireless network, then also we should be able to establish proper path between the transmitter and receiver. So whatever rules are set, that rule is called as medium access control protocol or MAC protocol. So let us see, this is the fifth lecture, it is given here. So there is a second lecture for today. Both this lecture PPTs I will be uploading, and both this lecture videos also I'll be uploading as I'm doing it on YouTube by today afternoon. Okay, so first see, this is a slide I had shown you previously. First see what are the issues, or what are the mainly problematic issues or challenges in case of ad hoc wireless sensor network. So issues is, first is medium access control scheme. That means if I'm deploying around 20, 30, 40, 50 sensors within a small area, if all of them are supposed to carry data from source to destination, then how they are retrieving the data through the air or through the medium. That is actually the medium access control scheme or medium access scheme. Routing is nothing but, I told you, defining the path from the source to destination, that is called as routing. So MAC we are going to see in this module. Routing, all the issues, different protocols are there, different methods are there, we will see in module 2. Multicasting, okay, multicasting, multipath, multi-hop, all those things are found in case of ad hoc network. So what trouble they are creating, that we will see in case of this. So OSI layer is there. So OSI layer is having nearly 7 layers. So transport layer is very important. I think it's the fourth layer in OSI. So what is the issue in transport layer in case of designing of ad hoc wireless network? We will see. Pricing scheme. So whenever it's ad hoc wireless sensor network, and if some service provider is there, how to decide the pricing scheme for all the bandwidth and all, that we will see in this case. Quality of service. So quality of service is something we will see in case of module 3. So module 3 is all about QoS, or quality of service. So quality of service actually is having three things in it. First thing is the data should be reaching from transmitter to receiver within time. Second thing, the data should be reaching from transmitter to receiver without any packet drop. So if I had transmitted 10 packets or 10 units of data, all the 10 units of data should reach from transmitter to the receiver. And third thing is all the data packet data should be unaltered. So the data should not be added with noise, data should not get altered while in the path of transmission or reception. So this is same as the way we are transmitting some letter or some something from this place, suppose to Delhi. We have done speed post. Okay, so the speed post should reach within 2 days. The speed post should deliver the same packet from here to the receiver, and whatever is written inside that letter, which is there inside the cover, it should not get altered in the process of transmission. So if all these three things are maintained generally, okay, there are a lot of other parameters of QoS, but if these three things are maintained, we can say we are offering certain kind of QoS. So QoS is a service quality that we are offering to our customers, okay, whoever is using our network. What is another issue in case of ad hoc wireless network is called as self-organization, because there is no base station in case of ad hoc network. All the nodes are supposed to organize themselves so that the data path from source to destination can be established. Okay. Security is a big issue in ad hoc wireless network. Security means because it's wireless network, in that case the security should not be breached from transmitter to the receiver. Okay. So security is a very big issue in case of ad hoc network. Next is network energy management. Just a minute. Okay, then next is energy management. So this ad hoc wireless networks are energy constrained because minimum amount of battery we are connecting, and we want the whole network should be working or functioning as long as possible. So we have to manage the energy of the whole network in such a way that the network lives for quite long, and it can transmit data from source to destination for quite longer period of time. Okay, so energy management is one of the very important issues for any ad hoc or wireless sensor network. Addressing and service discovery. Addressing means knowing who is the receiver, and through which path the data will be transmitted from the transmitter to receiver. So each node is having its ID. Source node is having its ID. So from source to the destination node, which are the intermediate nodes, their address, their path, their ID, all these things should be known during the routing process. Okay, so all these things should be known very well before the data is transmitted from source to the destination. So addressing and service discovery, that means path discovery, routing, through which path I should send the data, packet forwarding, all these things should happen seamlessly, very perfectly. So that is actually addressing and service discovery. Scalability. Scalability I had explained last day that initially suppose you have designed a ad hoc network for with 10 sensors and they are working fine. So now you want more accuracy. So more accuracy can in data can be obtained if I am inputting, if I am increasing the number of sensor nodes. So previously I have put some 5 sensor nodes and I was measuring temperature of a certain area. Now I want the temperature reading to be very perfect. So instead of 5, I will deploy 50 more sensors. So now it becomes 55 sensor nodes. So this is called upscaling. So more is the number of sensor, the data accuracy will become high. But this is called scalability, so upscaling. But as soon as I am increasing the number of sensor node, the bandwidth of each sensor node allocation, bandwidth allocation to each sensor node will reduce. In that case, what will happen? Though I am getting higher accuracy, but net output signal, it will reduce. Bandwidth will reduce. Okay, so there will be a lot of congestion in the channel. Data might not be transmitted from source to destination properly. So there is a scalability issue. So more sensor, more accuracy. More number of sensor, more congestion. Okay, less sensor, less accuracy. But less sensor, no congestion, proper transmission of data. That means whether to deploy more number of sensor node or whether to deploy less number of sensor node. This is a very big design criteria. Okay. So we are supposed to do some trial and error. So there are a lot of criteria through which we know, yes, if this is the area, if this is the distance between source and the destination, then this many sensor node will give me the best sensing with lesser wastage. So that is called as optimality condition. In scalability, this optimality condition has to be followed. What is meant by deployment consideration? So deployment, I told you what is meant by deployment. Whether you will go in the area and you just throw the sensors and the sensor will start collaboration and they will start receiving the data, sensing the data and transmitting. That is one type of deployment. Second is very properly you go and you just deploy, put all the sensors circularly in a circular fashion. So deployment is how you are putting the sensors in the area for proper kind of measurement. Okay. So deployment for cellular network is the time taking. Deployment for ad hoc wireless sensor network is very quick. Okay. Deployment in case of cellular network, it is costly. Deployment for ad hoc sensor network, it is less costly. So these are some of the issues which we have to keep in mind while we are designing a ad hoc wireless network. Go for the next slide. Please take a screenshot of this slide. I'm giving you some 5-10 seconds time because these are the page numbers from chapter 6 for MAC protocol for ad hoc wireless network. So what are the page numbers? Page numbers are page number 229 to 236, page number 243 to 246, and page number 270 up to 272. So whatever things are mentioned in your syllabus, they can be found in the book of Manoj, the PDF that I have uploaded in this pages. So page number 229 to 236, page number 243 to 246, and page number 270 to 272. And previously I had given you the page number of 206 to around 227 or something. Okay. So this all page numbers, if you have, you can go through from the book and your module 1 will be over. Now officially I am starting the syllabus and I'm starting whatever is given in page number 223 of the book of Manoj, and that will be what is meant by MAC protocol. So this I'm starting the syllabus with. What is MAC protocol? So what is medium access MAC protocol and what is the necessity of MAC protocol? I've already explained it to you. So MAC protocol is something like whenever nodes in ad hoc wireless network, they are sharing a common radio channel. So I told you that in one home, in one area, if there are 100 or 200 sensor nodes, then all the sensor nodes would try to access data from the air. Okay. And since the radio spectrum is limited, communication bandwidth for such network are also limited. Okay. So hence access to the shared media by all nodes must be controlled so that all nodes get fair access to the media and get enough bandwidth. The basic is the same bandwidth is shared by all the sensor nodes, and we have to define certain rules, and if each sensor node is following that rule, then only all the sensor node will be able to access data from that same bandwidth, which is common for all the sensor nodes. So it ensures, it means this MAC protocol ensures that most efficient utilization of bandwidth among all the sensor nodes. Media usage protocols for wireless are completely different than wired media access. So there are two kind of networks. One is wired network. Whatever electrical network we are having at our home, that is wired network. Bulbs, tubes, fans, everything is connected by means of wire. What is meant by wireless network is a ad hoc network, is a cellular phone network. So MAC is mainly applicable, or MAC finds its better use when it is wireless kind of a network. Okay? So media uses protocols for wireless are completely different than wired media access. Because for wired media, the MAC is comparatively easy. So there is nothing to control as such if the nodes are connected with wire. Because data path is defined at that time, there is no security issues at that time. Whatever is the data transmitted, that will reach to the receiver if it is wired media. But whenever wireless MAC is there, and that wireless nodes are also having some kind of mobility, in that case, limited bandwidth and error prone broadcast channel, hidden and exposure terminals, power constraint, all these things are creating a lot of problem, so that the communication will get disturbed. So what does MAC do? MAC actually does wireless network. They have defined the certain rules. If that is followed, then within the highly constrained environment of energy and bandwidth also, the nodes will be able to transmit data from one place to another. So this chapter 1 actually, the topic will be MAC, that is medium access and control. Issues in designing MAC protocol for ad hoc wireless sensor network. So what are the issues we have seen already? Some more issues we will see. Classification of currently existing MAC protocols. So there are some 3-4 MAC protocols we will be seeing, and whenever I am saying protocol means these are certain issues. Okay, these are certain rules that we are supposed to follow. So there is MACA, there is MACA W. Okay, there is BPRMA, something like that. So all those things, there is CATA protocol, there is HRMA. So all those protocols will be saying which are used for transmission of data from one place to another within an ad hoc wireless kind of a network. Okay, let's find out. So there is a very important question. What are the different design issues of MAC protocol? So if you are trying to design a MAC protocol, that how the data will be fetched from the same channel, from the same air, by all the ad hoc sensor nodes. So what are the rules that you have to design? So MAC design issues. So mainly MAC design issues are used for distributed allocation of the shared channel. So this is very important. Shared channel means the same air is being shared, same bandwidth is being shared by all the nodes of ad hoc wireless sensor network for transmission and reception of packets. Performance of any ad hoc wireless network, it depends on MAC protocol efficiency. So how well the MAC protocol is defining the rules so that the data transmission takes place, so the data sharing takes place, it defines the performance criteria of the whole ad hoc wireless sensor network. So performance of MAC, efficiency of MAC actually directly proportional to the efficiency of the whole network. What are the major issues of MAC that are given here? So there are many issues. I think there are 3 slides. MAC design issues. You can remember at least 5 to 10, and you should be able to explain 5 to 10 issues of MAC design and criteria. First thing, it's a distributed network and lack of central coordination. I have been telling you from the beginning, that is ad hoc wireless network is not having any base station. As there is no base station, there is no principal in the college. So what we are finding is centralized control is not there in case of ad hoc wireless sensor network. Hence, control the flow of information and overhead. Overhead means whenever you are transmitting the data from one place to another, so there is initially there is a request, there is acknowledgement, and then there is preamble. All these things have to be transmitted. Without that, you cannot only transmit the data, and you cannot expect that only data will be transmitted from the transmitter to receiver. So first there is a request, that one node will request the other, can I send the data now? So this is request for sending. Then the data will be sent. Data will be having its preamble, data will be having control bit, parity check bit, and all those things. They are not data. Okay, they are some kind of other things which are called preamble, and they are kind of overhead. Okay, so this overhead are actually creating, they are eating up a lot of bandwidth. So if data is, let's say, 100 bit, overhead is another 50 bit. Okay, so the total transmission packet becomes 150 bit. So this overhead sometimes, certain times, are eating a lot of bandwidth. But without overhead, we cannot have efficiency of data transmission. Okay. So what is distributed network and lack of central coordination? No centralized coordination is there between the moving nodes, and there is another problem. Biggest problem in ad hoc wireless network is all the data, all the nodes are continuously moving from one place to another. So in a highly mobile environment, how to keep the communication path intact and how to give you the best communication from source to destination, that is actually a very big challenge. Okay, so lack of central coordination is always playing a difficult part in case of ad hoc wireless sensor network, and there is a big problem while designing the map. Second is bandwidth. I told you this is the most important issue, that bandwidth is limited. Whenever I'm saying this is an ad hoc wireless sensor network, this will be designed, this will be assigned a bandwidth. Let's say bandwidth B. If you are deploying 20 nodes, each node will be having bandwidth of B by 20 hertz. If you are deploying 100 nodes, each node will be having bandwidth of B by 100 hertz. So it is up to us that we want to deploy a very big sensor network of very more number of sensors, or we want to deploy a less number of sensors. So this bandwidth, this maximizes bandwidth efficiency. So MAC main job is to maximize the efficiency of bandwidth allocation so that actual data transmission from source to receiver, and that does not get hampered. So how you are maximizing the bandwidth for every node, that is the job of MAC protocol. Synchronization, I told you, for ad hoc sensor network, synchronization is a big problem because certain nodes are on sometimes, certain nodes are off sometimes, certain nodes might die. Okay, and we don't know that it has died. We are trying to synchronize that, but it cannot be synchronized because it is already dead. Okay, so mandatory time synchronization among nodes for TDMA based transmission and reception is required. But due to bandwidth problem, due to battery usage, because for synchronization also have to send some packet, synchronization packet. Okay, that is also constituted within the overhead. Okay, so the collision of this packets, data packets, and all these things. So these are all adding to the problem in synchronization. That not every time it is possible to synchronize all the nodes. So some nodes might wake up at some time. At that time, other nodes are maybe sleeping. So that is a problem in case of ad hoc wireless sensor network. Access delay minimization. Access delay minimization means whenever you are trying to get the access of the medium. That means certain time it happens that we are trying to call somebody, but that person is unreachable because we are not getting a access for the bandwidth. So it is possible that our call will get delayed. So this is what is called as access delay minimization. So average delay that any packet experiences before transmission is called as average delay or access delay. So you're trying to access the channel. If you get the access of the channel, then only you can transmit the data. But to get the access of the channel, maybe the channel is busy and you are not getting the access of the channel. So before you are getting the access of the channel, whatever time delay is there, that is called as access delay. And less is the access delay, it is better for that part of the transmission. So MAC should try to minimize the access delay. That means whenever the nodes are trying to access the channel, that node should be given the access as soon as possible. Okay, so the access delay should be reduced as much as possible. What is meant by fairness? Fairness means all nodes should be able to transmit data. It happens sometimes in the network that yes, some node is piling up a lot of sense data. Okay, so sensing at that point is happening, and it is sensing a lot of data, but it is not getting enough bandwidth. It is not getting enough channel so that the data can be transmitted from the source to the destination. So all data gets piled up at the sensor node, and after a certain time, the data gets lost. So this is not a fair transmission. What is meant by fair transmission? As soon as the data is sensed, as soon as the sensor node wants to send the data, the channel should be allocated to it, other peer node should be allocated to it, so that the sensed data is transmitted to the destination as soon as possible. It should not happen that one sensor node is only piling up data, but it is not able to send the data to the destination and the data is delayed. So what is meant by fairness? Fairness is all transmitting nodes should get equal share of bandwidth. Fairness are node based, equal bandwidth and flow based data transfer. So multi-hub relaying fairness is must, else energy drains out. So all the sensor nodes should be given enough bandwidth, all the sensor nodes should be given enough time so that it can transmit data from close to the receiver. QoS support should be provided to all the nodes. MAC has to decide, or MAC has to ensure that with resource reservation mechanism, it should be able to provide best QoS. What is meant by resource of a network? Resource of a network are nothing but bandwidth and energy. Okay, so each sensor node should be having enough of power or enough of battery backup so that they are always active, so that they are not dead. And second thing is a very important resource is bandwidth. And third is channel allocation. So channel allocation, bandwidth, battery, they are some of the network resources. And medium access protocol, medium access and control protocol or MAC protocol, they should ensure that all these resources are equally distributed among all nodes. There should not be partiality. One node is getting too much time, too much bandwidth for data transmission, and another node is not getting any bandwidth for data transmission. This kind of thing should not happen. Same thing is called a resource reservation. So the MAC protocol should reserve bandwidth for every sensor node. That is actually happening in case of cellular network. That does not happen in case of ad hoc. But if that can be assigned by MAC, then there is nothing better than that. So resource means bandwidth should be allocated by MAC for every sensor node, and QoS, if the MAC can ensure QoS for bandwidth, delay, jitter, all these things for every sensor node, there is nothing better than that. Ability to measure resource availability. So at every second or at every instant of time, the MAC protocol should be knowing that how much is the resource available with any sensor node, and depending on that, the MAC protocol will be allocating the work to the sensor nodes. Okay. Hidden terminal and exposed terminal. What is meant by hidden terminal, exposed terminal? So these two things will be discussed later on, because this itself is a very big question. So hidden terminal is a transmitter. It's a transmitting terminal hidden from the transmitter but visible to the receiver. You cannot explain, you cannot understand this thing very clearly here. So I'll explain this hidden terminal and exposed terminal problem with the help of a specific slide to you in maybe tomorrow's lecture. Okay, and hidden terminal and exposed terminal problem has to be solved by MAC in case of any ad hoc wireless sensor network. So remember these two topics, we'll be explaining it tomorrow. Capability of power control, real traffic support, adaptive data rate control, all these things are the job that MAC protocol should ensure. Node mobility and throughput, very important thing. That's why I have put it in the red. Node mobility. So even if there is mobility of a node, even if the nodes are highly mobile, even if the path of the transmitter to receiver is changing, and that is very dynamic, then also the MAC should be able to allocate good amount of bandwidth to each of the sensor nodes, and then also the MAC should ensure that the transmitter to receiver path is kept intact. Okay, so that is what it is saying, that high mobility drastically affects the throughput. Throughput means output. So if there is high mobility in the node, then the path might break. If the path is breaking, in that case output becomes less. So path means communication path. Resource reservation by MAC will be fruitless for such high mobility. So even if MAC is working very well, but suddenly there is a path break, then there is no point of all these rules of medium access control and all. So MAC design should consider mobility. So how much maximum mobility is allowable in case of an ad hoc sensor network, that the MAC should decide. That if dynamism is this much, then also I am able to handle it. But too much dynamism in network and too much dynamism of nodes, then MAC says that yes, I cannot work any better and I cannot handle it anymore. Okay, so MAC design should consider mobility, how much mobility is allowable for perfect data transmission. Minimize collision not of nodes but collision of data packets. Okay, so more is the node mobility, there is a chance that data packets will get collided more. So more is the packet collision, less will be the output. So throughput will reduce if more is the collision. Minimize control overhead. Okay, so control overhead are those, so CTS, acknowledgement and request to send, request to transmit, all those things are kind of overhead. They should be as less as possible. They should not also get collided with each other. In that case, the control overhead will be lost and MAC will not be having control over ad hoc wireless network. So minimize the control overhead and maximize channel utilization. Maximum channel utilization means the communication channel should not be left blank. That is first thing. Communication channel will be always used, but communication channel will not be overused. It should not happen that. So there are two extreme cases. One is channel is blank. There is no data to be transmitted. Though there is sense data, but because of improper channel allocation, the data are not put on the channel for transmission. So that is the worst case. Like computer lab in our institute, computer lab is there, students wants to use computer, but we are not able to put or allocate proper timing so that students are using the computer. So that is called as worst channel allocation. Second thing, overuse means huge amount of data is sensed and huge amount of data is we want to transmit over the same channel, and channel does not have that much capacity. In that case also this is a problem. So underuse of channel, overuse of channel, both are not expected. So proper usage of channel is air through which the data is transmitted. Okay, so that has to be controlled by MAC protocol, like that. An error prone share broadcast channel. So whenever there is a channel, it will add some noise, it will add some bits and all, and it will add some erroneous message to the data. So MAC has to ensure that this error added to the data is as less as possible. So these are the three slides. I have given many points, around 20 points are given, around 16 to 17 points are given. At least 10 points you should be able to explain very properly in case of MAC design issues. So MAC design issues can be a question for 10 marks. Explain all the MAC design issues in case of ad hoc wireless network. So please prepare this question. Second thing is design goals of MAC protocol. So whenever I am designing a MAC protocol, what are the things that I have to keep in mind? So the things that I have to keep in mind is already told to you. Collision is one thing, collision should be avoided. Bandwidth is one thing, bandwidth should be as high as possible. Hidden and exposed terminal problem, they should be solved. So what should be the design goals of MAC protocol? That is explained in this slide. So what are the design goals? First thing, operation of the protocol should be distributed, because there is no centralized control, there is no base station. So it should be a distributed control. This is what is the design. It should provide quality of support for real-time traffic. So what is meant by quality of traffic? Three things I told you. Again I am repeating. First thing is data should reach in time. Data should reach in proper quantity. So if you transmitted 10 packets, 10 packets should be received. Third thing, data should be unaltered. So whatever you have transmitted, the same amount of data should be received. So these three things are quality of service. So MAC goal is, MAC should ensure that all this quality of support is provided for the real-time traffic or data packet. Access delay must be as less as possible. So previous three slides I told you what are the parameters. In this slide I am telling you this parameter should be high, low, or how much. So that is actually design goal. So each parameter is design issue, and then it should be high or low or good or bad or positive or negative. That is actually design goal. So access delay should be as less as possible. Available bandwidth must be utilized properly. Okay, so perfect utilize of bandwidth. It should not be free. The bandwidth of channel should not be free. The channel or bandwidth should not be overcrowded. So both the things we have to design. So that is called optimality and most efficient use of bandwidth. So that we have to see. Protocol should ensure that fair bandwidth allocation to all nodes, equal and weighted. So that is one thing, fairness of transmission, that all the nodes should get chance to transmit the data. All the nodes should be given equal share of data transmission. Otherwise what will happen? Either that it will be lost or data will get piled up, and that will congest the overall channel and bandwidth. That should not happen. So protocol should ensure, MAC protocol should ensure that bandwidth allocation to all nodes are equal and weighted. Control information overhead, that is CTS, RTS and all those things, by mobile nodes to the network media must be as low as possible. Okay, so there should be data as much as possible. There should be less overhead, control and communication overhead should be as less as possible. In that case, that will reduce the wastage of costly bandwidth. So bandwidth should be used best for only for data. Overhead are must. We cannot say that we are not going to use overhead, because they are the signals that actually initiates or terminates the whole process. So overhead should be there, but overhead should be as less as possible, because more overhead, more is the wastage of bandwidth. So we should reduce the overhead. Protocol should minimize the effects of hidden and exposed terminals. I told you I'll explain it to you in the next lecture. So hidden and exposed terminal problem should be reduced. Protocol should have proper control mechanism in order to efficiently manage energy usage and energy consumption by the nodes. Okay, so energy consumed by the nodes should be optimal. It should not be more, it should not be less. Whatever is required, that much energy should be used. Protocol should try to use directional antenna which reduces the interference. Protocol should provide time synchronization. So by means of a protocol only, MAC protocol only, we should be able to get time synchronization among all the nodes or as much as node as possible, because we have seen initially that ad hoc sensor network is having a time synchronization problem. Then also whatever best we have to achieve through MAC protocol. This is the classification of MAC protocol. So this very big tree you can find in book. Okay, we are not supposed to read the whole tree. This will not be asked in the exam. But yes, as per our syllabus is concerned, we are supposed to go through these three protocols. Okay, at least one protocol of each. So these are the three main head of protocols. First one is contention based protocol. Okay, so what is meant by contention based MAC protocol? Second is contention based MAC protocol with reservation mechanism. That is the second type. And third thing is contention based MAC protocol with scheduling mechanism. So three types of MAC protocol. First one is contention based, second one is contention based with reservation, third one is contention based protocol with scheduling. So all these three things we will see one by one. Let me just tell you what is meant by contention based protocol. So another 5 or 6 minutes I'll continue. So let us see what are all these protocols. So what is meant by contention? Contention means there is an air channel and there are, let's say, 50 sensor nodes within the ad hoc wireless network. Okay, so each of these 50 sensor nodes, they are trying to catch hold of the bandwidth, or they are trying to catch hold of the channel. Okay, so that is called contention. What is another thing? There is one post. So I'll give you another example. There is one post. Suppose vice president of a company, and there are 5 contenders. IPL. How many cup? Only one trophy. How many contenders? There are 8 teams. Okay. So contention means who is going to catch hold of the trophy. That is meant by contention. So what is the trophy here in case of ad hoc wireless sensor network? Ad hoc wireless sensor network, the trophy is the channel, and there are many sensor nodes. Which sensor node is trying to get the channel for data transmission? Every sensor node is having a lot of data, and that they want to transmit to the receiver. Okay, so contention means the act of competing as for a profit or a price. What is the price here in case of ad hoc network? It is the channel access, or access to the channel. So there are 3 protocols I told you: contention based with reservation, contention based with scheduling. So first is what is contention based MAC protocol. It says that this protocol follows a contention based channel media access policy. It wants to catch hold of the media, that is the channel through which it can transmit information. Node does not have a priori reserved resource. So node is not allocated that channel. It is not that, okay, this node will be having time to transmit its data through the channel. So there is no reservation. What is meant by reservation? Yes, this node will be transmitting through this channel always. In that case, this is called the channel is reserved for this node. But such reservation, permanent reservation, is not there. Each node has to fight with each other to get or to catch hold of the channel for transmission. That process is called as contention. So node does not have a priori. A priori means from the beginning. Node does not have a priori reserved resource. That means nodes are not allocated the channel permanently. When the node receives a data packet for forwarding, so first the node senses the data. That means a packet is ready for forwarding, or it is receiving a data from the previous node, because this is a router node. So this is receiving a data from the previous node that it has to be forwarded to the next node. So when the node receives a data packet for forwarding, it contends, or it starts fighting with its neighbor node, so with other nodes, for the access of the shared channel. So this third line is very important, and this is telling you what is meant by contention. We will do only one protocol today, that is only contention based MAC protocol, and this is probably the last slide. Okay, So this is what it is when a sensor node wants to forward a data packet, or it receives a data packet from the previous and it wants to send the data packet to the next. Then it starts fighting that yes, I'm having a data packet, I want to transmit it to the next node, or I want to transmit it to the next packet. So I want a channel. So it starts contending or fighting for the channel access. Contention based protocol cannot provide QoS guarantee to sessions since nodes are not guaranteed the regular access of channel. Even if you're fighting, not necessary that that node will be given the access. That means there is no guarantee that whatever packet the node is receiving, that will go to the destination very fast. So that is what it is saying. Contention based protocol cannot provide QoS guarantee. QoS guarantee is timing guarantee. So one of the very important thing is QoS is timing. So there is no guarantee that that packet will be sent to the receiver within proper time. So contention based protocol cannot provide QoS guarantee to session since nodes are not guaranteed regular access of the channel. Random access contention based protocol are of two types. So this is called random contention based access, that yes, some node accessing, some node asking for contention given, and some node finishes its job, it comes out of the contention. Okay, so that is actually a random contention based protocol. They are of two types. In first case, sender node initiated packet transfer protocol and receiver node initiated packet transfer protocol. In first case, sender node is asking for a channel to transmit the data to the receiver. It is single channel sender initiated protocol or multi-channel sender initiated protocol. So it can happen that one sensor node is having some data to be transferred, and it can book one channel, or it can book many channel, or it can fight for one channel, or it can fight for many channel to transmit that set of information to the receiver. So if one node is fighting for one channel from the source to the destination, then it is called single channel sender initiated protocol. If the one sensor node is booking multiple channel, then it is called multi-channel sender initiated protocol. In multi-channel sender initiated protocol, the bandwidth is divided into multiple channels. Several nodes simultaneously transmit the data over a separate channel, and separate channels are allocated for control info transmission. What is meant by receiver node initiated packet transfer protocol? The receiver knows that I am supposed to receive the data from certain transmitters. Then receiver will book the channels so that those transmitter can send the data to the receiver. So in the first case, sender books the path for forwarding. In the receiver node initiated packet, the receiver books the path for packet transmission. Then this is the second part, which is called as contention based MAC protocol with reservation mechanism. This is better than the previous one. There is a contention based MAC protocol simple. Okay, so this we will do next day with reservation mechanism and with scheduling mechanism. So first part and most primitive part is contention based MAC protocol. And mainly we will be doing contention based MAC protocol. There are two protocols we will do, MACA and MACA-W. Contention based with reservation, contention based with scheduling, we will see next day, and we'll enter the main part of MAC protocols as given in the module 1 syllabus. So whatever is taught in these two sessions, I will send the data, I'll send the PPT for this, and book is already given to you. All these things are taken from the book of Murthy, so I'll not be sharing any notes as such. I'll be sharing only the PPTs with you, and I'll be sharing the lecture videos. And lecture videos will be shared in YouTube.